You might recall from a previous chapter seeing a contingency table like the one on the screen in front of you right now, where we have marital status, various levels of marital status represented in the columns, and then various levels of happiness represented in the rows. And at the time that we covered it before, we probably would have asked you to look at that contingency table and decide whether or not there was any kind of relation between those variables, or whether they were independent or not. And so what we want to look at here is a chi-squared test that allows us to assess that a little bit more formally. This is the chi-squared test, which is used for independence. And as it says, it's used to find whether there's an association between two variables. So an association or a relation or a connection, something like that. They're all asking the same thing. We want to know, are they independent or not? Now, one thing that's important to remember, when you do a hypothesis test, we assume that the null hypothesis is true as part of the process. And so if you'll notice here, when we do this particular test, this chi-squared test for independence, the null hypothesis is that we have independence, and we are assuming that that is true as part of the process. Now, if you remember back in a previous chapter when we talked about independence and probability, there was a very important equation that was presented, and what it said in effect is that the probability of two events, E and F, is equal to the probability of E times the probability of F when the two events are independent. And so we are assuming that we have that here when we do this particular test. Now, as far as what you see in the book, the process that's laid out there is fairly intricate, and I'm not going to cover it all in great detail. I'm assuming you can read it as well as I can. What I'm going to show you in this video is how we would use the calculator to quickly and efficiently apply a test for independence. And you can refer to the text because we're going to use a prepared example from there, the one that you just saw on the screen previously regarding marital status and levels of happiness. And so if you'd like to follow along, we will show you how you can key this in to your calculator and how you can do this test very quickly and efficiently. It turns out that the various models of TI calculators have a built-in test which can be used for this if you know how to put the data in. And so the test that I'm referring to is on the TI-83 as well as the TI-84. If you go to the Stat menu and you go to the Test submenu and then you go up, it is letter C on this particular menu, the chi-squared test. And what makes this difficult for people to do is that the data is required in a matrix form. And so they have to be able to key that in, and most people don't have experience keying in a matrix into a graphing calculator like this. So we're going to show you how to key in a matrix, but let's take a look at what the test is expecting first. So you'll notice that it has observed and expected, just like the goodness of fit test. But the way it writes those is a little bit different. You'll notice that there's brackets and then there's a capital letter. And those are the names of matrices in the calculator. And so if you'd like to see where you would find them, you can exit from here. And you'll notice that right above the x to the minus 1 key, there's a blue matrix. And so to access that, you'd press second, x inverse. And here you have the names of the matrices. And they don't have anything in them right now, but they will once we've keyed it in. And so in order to key in data into a matrix, you need to go to this menu here and then press the right arrow key to edit. And then you want to select the matrix that you are interested in editing. Now, if you recall, in the test we were looking at, we had observed in matrix A and expected in matrix B. And so if you follow that and use that as a default setting, that's good. You can just continue to reuse those matrices as needed. Let's take a look at keying in some of the data from the problem. The table that you see in front of you here in the text is the observed counts. And so this is what you'd want to enter into matrix A. And so if you'd like to follow along using your calculator, feel free. You can get this information from the text, and so that may make it a little bit more convenient, or do whatever seems good to you. You can pause the video if you want, but we want to key this in, and so we're going to do so as follows. We go back to the calculator And as we said before, we want to be editing a matrix. So you need to make sure that edit is highlighted up here, and it's matrix A that we're going to edit. And so to start that, all you have to do is press enter. And you'll notice that the first thing it's asking you is the size of the matrix. And so if you're looking at the information in the text, whenever we give the size of a matrix, we always tell you the number of rows first, and then we tell you the number of columns. And so for this particular matrix, you might notice that there are 3 rows and there are 4 columns. So the size of this matrix is 3 by 4. And so you'll see now that the matrix has the number of cells that you would want. Now you can start keying it in. So the married, very happy is 600. And in order to key that in, you just go back to the calculator, 600, and press enter, and it moves to the next entry, as you can see. So let's get this keyed in. So after you've keyed in those observed counts, your matrix should look like this. And now you're ready to key in the expected counts. So you'd want to leave this, go back to the matrix menu, go back to the edit submenu, and you want to start editing matrix B. Now matrix B and matrix A have to be the same size in order for this test to run. And so if you want to get started, matrix B is also 3 by 4. Now this is where things get a little bit slippery, because if you look at what we have in the text, there's a very lengthy discussion of how to obtain these expected counts. The crux of it is to remember that we're assuming that we have independence. And so in other words, what we want to do is we want to calculate the probability of each of the cells, or the probability associated with each of the cells. And then we want to scale that to match the sample size. And so again, if you go back and look at what we have in the text here, for example, right here in this cell, we have the intersection of the very happy row and the married column. And that intersection right there represents the event very happy and married, or married and very happy. It's the same thing. And so what we want to do is we want to come up with an expected count that corresponds to that, which is based on our sample. Now in this particular version of the table, you'll notice there are no marginal distributions. And so it's kind of a lengthy explanation, but they show it in the text how they obtain those. I'll be straight with you. Generally, if I'm going to ask you this kind of a problem on an exam, I'm going to provide those marginal distributions, because we figure at this point it's a waste of time to have you adding stuff up like that on an exam. I mean, this is an exam that's asking a higher level question rather than just simple arithmetic. So generally we will provide those, but they don't always provide them in the text. And so sometimes you have to construct the marginal distributions. In other words, the column sums and the row sums. Now, in order to save some time, I'm going to switch to a different version of this table where that's already been done, and then we'll show you how to get those expected counts. Now, I would strongly encourage you to read this portion of the example carefully in the text. It would make a lot more sense if you have it in front of you. But what we're looking at here is how to obtain those expected counts. And if you remember, we're assuming that we have independence. And so, for example, if you're looking at this first cell right here, and you want to know what is the expected count for very happy and married, what you need to know is what's the probability of being very happy, what's the probability of being married, and then scale it so that it matches the sample size. Now, if you're calculating the probability of being very happy, you would take the row total, which is 919, and you would divide it by the grand total, which is 2985. And then likewise, if you wanted to find the probability of being married, you would take the column total, 1413, and you would divide it by the grand total, 2985. And so you can calculate the probability of being very happy and married by taking those two probabilities and multiplying them together, because again, we're assuming that we have independence. And then you would scale it to match the count of the sample size, because in this case the sample size is the grand total, 2985. So you would take that probability and then multiply by the grand total, and that will give you your expected count. And so you're going to do that for every cell. And it is a bit tedious, but if you practice a little bit, it doesn't take that much time, and it becomes very, very straightforward. Let me show you how that's going to look on the calculator. The key to getting this done quickly and efficiently is on the screen right in front of you here. So I would encourage you, again, read this very carefully and make sure you understand the details. But the bottom line is that we're going to enter what is effectively this calculation here, but we don't quite type it that way because, as you can see, the calculation simplifies. And so for each of the cells, what we're going to be keying in is just what you see there on the last row. We're going to take the row total, and we're going to multiply by the column total, and we're going to divide that by the table total. So for the first row and the first column, it would look like this. So as you can see, we have our row total, which is 919. We have our column total, which is 1413. And we're dividing that by the table total, the grand total, 2985. Here's what we get. That's our expected count for very happy and married. And we're going to do the same for the rest. So for example, the next one, which would be very happy and widowed, we have a row total of 919. We have a column total of 256. And we're going to divide that by the grand total. And there's our expected count for widowed and very happy, or very happy and widowed. And so let's do the rest in the same fashion. So here's our matrix completely filled out. And again, what we were doing in each of those cells was as follows. We were taking the row total times the column total and dividing that by the table total. And so you can compare what we had on the calculator with what we have here in the text. And so you can see here in table 8 that we have our expected counts. Now once those are in place, you're ready to run the test. And so let's take a look at the calculator again. So we have matrix B finished, and we want to quit this. And then to execute the test, we're going to go back to the stat menu, go to test, and we're looking for the chi-squared test. Now the beautiful thing about this test here is that the calculator takes care of all the heavy lifting. So all you have to do is make sure you have your observed counts in the right place, your expected counts in the right place, and then the calculator will cough up everything else. And here's the result. So we have our chi-squared test statistic at the top, we have our p-value, and we have our degrees of freedom. And so we would want to record these, as is our usual procedure. So the generic hypotheses for this test would be that the variables are independent versus the variables are not independent. If we contextualize them for this particular example, the null hypothesis would be that there is no association between happiness and marital status, or if you prefer, there is no connection between happiness and marital status. And we're contrasting that with the alternative hypothesis that says there is some kind of an association between happiness and marital status. Now, as you saw when we ran the test, we got a test statistic of 224.1156 and some change, and we got an incredibly small p-value of 1.379 times 10 to the minus 45. So if you look at the calculator again, one thing that we're definitely expecting is that you can look at a p-value that's given in that way on the calculator and understand what it means on a practical level. That is the calculator's way of showing the scientific notation. And so I'm not going to write this one as a decimal because it has a good number of decimal places before the first non-zero digit. But anyway, we hope you'll look at that and realize that is a very, very small p-value. And so even if they had not given us a pre-selected level of significance in the test, or in the problem rather, we would be rejecting the null on that basis. And so for stating a practical conclusion, that's what we would want to say. So we're rejecting the null, and what that means on a practical level is that the evidence shows that there is a connection or an association or some kind of a relationship between marital status and happiness. In the next video, we're going to look at another example, a little bit more subtle, of this very same test in action. If you have any questions, please feel free to drop me a line.